Hello, and welcome to part 2 of building a plasma toroid. If you missed my first episode, I'd highly suggest you check it out. I'll leave a link up here as well as in the video description. In today's episode, we're going to dive into testing, troubleshooting. We're going to build a second circuit board, and foreshadowing, at the end, you'll get to see some plasma. So stay tuned. Please don't jump to the end, and let's dive in.
All right, let's plug in this. All right, here goes nothing. Let's turn off the lights. Slowly advance knob until run lights, then long press the button. Okay. So we got power. We need to slowly advance this. That's all the way forward.
This is Chet from the future here. I took a multimeter and checked the voltage only to realize I forgot to cut the pads on the breakout board. Once I did that, I was able to increase to 20 volts with a 3 amp limit.
I think I might have fixed the issue with the power supply. Let's just try it out. Okay. Orange light looks good. I hear a fan now. That's also really good. Let's try to crank it up. Looking for the run light, but I don't see it.
Two hours later.
Give it the beans. Well, that ain't good.
The next day.
So just diving into it, I'm going to try to build another circuit board. One of the reasons why is I wasn't confident that I didn't overheat the components when I used the hot air station last time. So just going to assemble a new board, and this time I'll use a reflow oven that should take it just to the temperature to reflow the solder and hopefully not overheat the components. Just speeding through this time lapse, you can see the components that are surface mount ready to go in the oven, and through-hole components will be added shortly thereafter. Borrowed this, just got a wave 1 mode, takes it to 250C, and then right back down. So did a nice job reflowing the solder and only bridged that small U1 chip. So got some solder wick, some flux, and fixed that up. Looked pretty good after some IPA, and then it was on to adding the through-hole components again. So using my blue tack, soldering those potentiometers and headers, and made quick work of that. And with that, I was ready to put on the striker wire and clean it up. Again, this heatsink is super easy to add. These spring-loaded screws, or whatever you want to call them, that's very easy to install and remove as well. And then after that, put it on the mount, screwed it in, just enough to hold it together. And I'll turn it over and plug things in a second. So connecting the fan, connecting the power, so you can see that. And with that, we're ready to put the ball on and try it again. So we have the new PCB here. Here's the old PCB. Had to solder on L1 by hand with legs. Really messed up my through-hole connectors there in trying to fix L1. I'm not saying this is a bad job, I just don't know if this is potentially why it wasn't working for the first try. So we're going to try turning it on. Hear the fan running, that's a good sign. Oh, it's tripping. Let's pause there. That's a really good sign. All right, we're going to try a slightly different approach. I've got a different power supply that should be able to do more amps. Green light. All right.
20 minutes later.
Alright, let's try it again. Wait, I can see it.
5 minutes later.
Come on, come on! Yo! Yo, come on! Look at that! Look at that! Yo! It's causing my power supply to glitch, but it's going. What the heck? Yo! Whoa, I just saw it! What?
Wow. I mean, what else can you say after that? Getting plasma streamers, and for a few brief moments, a plasma toroid was so exciting. And before we wrap up, I do want to emphasize we're not done yet. I want to try to get this thing running for about 5 minutes as my original requirement. I haven't gotten that yet. I will get a better power supply and also some ferrite beads that should hopefully limit the high frequency interference. Aside from that, I do want to emphasize this project was designed by Sky Guided, but it's based off the work of many others, and I want to point you to their channels. Human, BackMacSci, Steve Ward, the original designer of this oscillator circuit. Keep watching. We'll try to get this thing running for a bit longer in the next episode. And with that, I'm signing off.